Now you can start talking.
Okay, so hello everybody. Hello everybody. We're going to do a presentation about continuous delivery. So these are some of the concepts we're going to talk about during this presentation. Let's start. Question: what is continuous delivery? Let's talk about it. Continuous delivery is a very innovative concept in software development. Thanks to this practice, production phases, which include development, quality control, and delivery, are not finite. They are repeated in an automatic way over and over during all the development process through a continuous delivery pipeline. Here, the pipeline can be represented with this image of this slide. And this pipeline gives us a constant feedback, which lets us improve the software in an immediate way after modifying the source code. So the use of this practice has some advantages, like, for example, efficiency and quick delivery of the product, but these advantages will be explained later by one of my colleagues. And continuous delivery may be similar to continuous integration or deployment and DevOps, but they are not the same. This will be also explained later with more detail.
Okay, I'm going to talk about the relationship between continuous delivery and DevOps. Continuous delivery is a software engineering approach in which teams produce software in short cycles. On the other hand, DevOps isn't a software engineering approach, it's rather an approach to culture, automation, and platform design. DevOps is intended to deliver increased business value and responsiveness through rapid, high-quality service delivery, which involves a set of practices which aims to shorten development cycle, providing many things, usually including continuous delivery. Also, continuous delivery is often used in DevOps alongside continuous integration. Both are often referred as the continuous integration continuous delivery pipeline, with development and operations teams working together in an agile way.
The main advantages are the following ones. Starting from the efficiency, since with this method everything but the deployment is automated, and this way a lot of development and testing saves a lot of time. Before the deployment, every important feature is well tested, and this is the reason why all the bugs that could appear in the release day are already fixed, and so it minimizes the errors, or at least generally the most important ones. Most of the times, maybe development teams don't have enough feedback with the stakeholders, or in the other hand, the user feedback that the chain of one app or one specific functionality doesn't work as well as expected. So by this approach, developers can know much quicker where are the parts of the application that can be improved, and this way, all the users, or most part of them, feel comfortable using the application, because in the end, they are the ones that add value apart from the stakeholders. As with this approach, a lot of time is saved by having the updates ready to deploy at any time, putting on the market in a fast way. This puts the company very advanced, respect the other ones that are competing directly with them to make a similar functionality for their application. But this strategy is very important to get the users to use your application. And another good advantage is the way that all of this affect directly to the team that works on that application, according to their mental health. This means that having everything about the development and well-automated tests, they do not have to be worried if they must waste their spare time going to the office or crunching extra hours at home on the weekend. And on the other hand, we have the drawbacks. To start, maybe if one functionality is working well and users love that part, even if the developers update that part with a new, more sophisticated part, and the way to use it is more efficient, sometimes users don't like that change, and they may start using less application or maybe change to another one from the competence. Some tests may not be feasible to automate, needing human treatment in between to make it work properly. So this can be a bad thing from the efficiency point of view. And time to market strategy, but necessary to sacrifice it if the application must be well tested. For some applications like the ones used for medical purposes, for example, or the ones that need to work as they are expected to do, like real-time machines, Everything must be well tested until the point that it's crucial that everything works well before the release day, having to automate more tests than maybe the ones that an average application can need. From another perspective, there can also be cases when the tests are not enough automated. This case is usually taken by developers, avoiding them from applying well continuous delivery, so they feel less confident, and when they must make their own tests, they must work much more than if they were applying continuous delivery just from the beginning.
So tools. There are many tools in the market that accomplish the different processes of continuous delivery. These tools are the components of a delivery pipeline that constitutes continuous delivery. Based on the categories of delivery process, we will study some of these tools. But first of all, let's talk about Buddy. So what's Buddy? Buddy is a smart continuous integration, continuous delivery tool for web developers designed to lower the entry threshold of DevOps. It uses delivery pipelines to build, test, and deploy software. Now we'll talk about Eclipse. It's a Java-driven platform that enables developers to create a customized environment for development. It is the most commonly used IDE. Well, there's no need or more explanation of Eclipse because we all know it. And in the testing part, Selenium is a very user-friendly and portable software testing tool, which is used to test web applications. It comes with a very good feature of record play, which can generate a script by recording test steps. Let's talk about differences between continuous integration and continuous delivery, because most of the people don't understand them. So in continuous integration, developers' changes are validated by creating build and running automated tests against the build. It puts a great emphasis on testing automation to check that the application has no errors when new commits are integrated into the main branch. And continuous delivery is an extension of continuous integration. It's like if it goes one step further of continuous integration. On top of automated testing, you have an automated release process, and you can deploy your application at any time by clicking a button.
Most people tend to call continuous deployment when they really refer to continuous delivery or vice versa. Although they are not completely wrong, the main point is that differentiates continuous deployment with continuous delivery. It's just that in the delivery, deployments are the only thing that is not automated. So we can say that continuous deployment has the same phases in general than continuous delivery, but for all the case, they also automate the releases. When with the delivery, they just do it manually. This way, every change that passes all the stages and tests from the production pipeline is directly released to the customers without any human intervention, preventing this way the internal pressure that a team could have due to a specific release day. So maybe with this approach, we could say that continuous delivery could also have that drawback.
Okay, and now I'm going to talk about the deployment pipeline, that is the pattern used by continuous delivery. So usually, continuous delivery is slowed down because of different problems and bottlenecks that occur during the development process. For example, build teams can be waiting for some documentation or fixes, or maybe testers can be waiting for good builds of the software to test, etc. So there are several ways in which software delivery can be improved, but the deployment pipeline is the pattern that gives more information about the bottlenecks, where they are, and how to optimize them. A pipeline is a set of automated processes that allow the developers to compile, build, and deploy the code in a fast and reliable way to the production platforms. The key objective is the automation of the steps that are most commonly repeated. This way, the human errors caused by boring and repetitive actions are mitigated, and the work is more efficient. To achieve this, the team has to configure and automate large parts of the build, deploy, test, and release processes, so that it is possible to deploy the app to any environment, testing, or production very easily. This way, they can deploy it to an environment more times and get some feedback. Developers must be aware of which builds have been through which environments, the problems found there, and also the managers can obtain different metrics such as the cycle time, the throughput, the code quality, so that everybody in the development process accesses the things they need when they need them. Although there is no specific way of designing a pipeline, the most common stages are these four. First, the commit stage asserts that the system works at a technical level. This means that it compiles the code, passes a suite of unit tests, and runs the code analysis. Then we can have a set of automated acceptance tests that check that the system works at a functional and non-functional level, that it meets the needs and the specifications of the client. Then we can have manual tests that assert that the system is usable and fulfill the requirements, and also can find some errors that were not caught in the automated tests. And finally, we have the release stage. In this part, we deliver the system to the users, maybe as a package of software or by deploying it to a production or a staging environment. A staging environment is a testing environment that is identical to the production one. And finally, the key purposes of this pattern are these three. Visibility. All aspects of the delivery system are visible to every member of the team so that they can collaborate in the building, the deploying, the testing, and the releasing parts. Then the feedback. All members of the team can be aware of the problems as soon as they occur, and they can be able to solve them quickly. And finally, the continuous deployment. Through a fully automated process, any version of the software can be deployed at any moment to any environment.
I'm going to talk about strategies for overcoming adoption challenges of continuous delivery. Liang Ping Shen, an independent researcher and consultant who works at Huawei, wrote an article presenting several strategies to overcome continuous delivery adoption challenges. Selling continuous delivery as a painkiller. We identify each stakeholder's pain points that continuous delivery can solve, so we can convince them and achieve the wide range of stakeholders that a continuous delivery implementation usually requires. Dedicated team with multidisciplinary members. It's hard to progress with a team with responsibilities in many projects, so a dedicated team is often recommended. Also, this strategy puts emphasis on having multidisciplinary members to smooth the communication with related teams and provide the wide range of skills required for continuous delivery. Continuous delivery of continuous delivery. This can be a little confusing at first, but what this means is just to organize the implementation of continuous delivery in a way that delivers value as early as possible, like we do with the software. Starting with easy but important applications. We have to choose the ones that are easy to migrate, but also we have to choose the ones that are important to our business, so we can demonstrate continuous delivery benefits quickly and prevent our implementation initiative from being killed, because we will be quickly building value for our company. Visual continuous delivery pipe skeleton. It's just to give a visual skeleton with the full pipeline. This is especially useful when the migration requires mindset changes and large efforts over a large period of time. Expert drop. It's a good idea to assign a continuous delivery expert to join top projects as a senior member of the development team, so we can build the motivation and help maintain momentum when the migration requires a large effort over a large period of time.
So that was the presentation. We hope you enjoyed it.
Okay, thank you. Now we have time for questions. Who wants to do the question?
Me, for example.
Okay.
Well,